We're back to Spearman's rank correlation. Last week, we looked at the correlations of rankings with competition judges and preference rankings to determine agreement between two parties. So assignment 5 asks us to look at data that isn't ranked, rank it, and then say something about that data. Let's go ahead and read the problems. The population percentages for 5 demographic groups are provided in the table below, so this table here, with their relative rankings. So we can notice some things here. Some populations are going up and some are going down. So for example, we've got 3 different time frames, 1980, 2010, and 2040. And if we look at the white demographic in California over this period of time, they're decreasing over time, whereas the Latino population is increasing. It's asking us to determine if there's a correlation between population rankings between 1980 and 2040 and 1980 and 2010. So what this means is that if there were a strong positive correlation in this data, a high population demographic would stay high and a low population demographic would stay low over time. A weak positive correlation would mean that for the most part, lower population percentages would stay low and higher populations would stay high. However, there might be some significant exceptions. Problem number 1 asks us to examine the scatter plot for the 1980 and 2040 rankings. The first observation that I could make is it looks like there is a fairly strong positive correlation between the ranked data sets. A second observation that I could make is that 2 of the data points switch. So, for example, rank 1 in 1980, rank 1 here in 1980 becomes rank 2, and rank 2 in 1980 becomes rank 1 in 2040. Similarly, rank 3 becomes 4, and rank 4 becomes 3. So I can say that 2 data points switch and 1 data point remains the same. Problem 2 asks us to estimate the rank correlation for the 1980 and 2040 population rankings. And then it wants us to check our estimate by calculating the rank correlation. Because this looks like it's a fairly strong rank correlation, I'm going to go ahead and say that this is probably around 0.8. But then I actually have to go through and I have to calculate that. So I'm going to go back to my original graph and I'm calculating the difference between these ranks here and here, here and here, here and here, here and here, and here and here. To find the differences between the rankings, I'm just going to list them. So I'm going to list the 1980 population ranks next to the 2040 population ranks, and I have and. So I'm going to find the differences between them. So the differences are 1. And then I'm going to square those differences. And that's really easy because these are all 1. If I square the differences, I get 1 squared. So my result is, which is 4. So I now have the sum of the differences squared. The formula for Spearman's rank correlation is, so I know that my sum here is 4, the number of rankings here is 5, so R is 1 minus 6 times 4 over 5 times 5 squared minus 1, which is 24, which is equal to 0.8. Problem 3 asks us, would you expect the 1980 population ranking and the 2010 population ranking to be smaller or larger than the one computed in problem number 2? This one is more of a conceptual question. We're looking at the difference between the populations in 1980 and 2040. We've already looked at those. And now what we're trying to say is, would we expect there to be a higher correlation or a smaller correlation in 2010? I would expect the correlation between the 1980 rankings and the 2010 rankings to be larger than the one I computed in problem 2, because in less time the population rankings wouldn't be as likely to change as much. Problem 3A asks us to compute the correlation between the 1980 population ranking and the 2010 population ranking here to see if it confirms or contradicts our expectation. So I'm going to compare the 1980 population ranks to the 2010 population ranks, and I'm going to make these lists on my paper to do the calculation like I did in problem 2. So R is equal to 0.9. If I compare that to the correlation ranking between 1980 and 2040, which was 0.8, I see that 0.9 is larger than 0.8, which is what I had initially said. Therefore, the correlation between the 1980 population ranking and the 2010 population ranking is 0.9. This confirms my expectation because it is higher. If you have any additional questions about assignment number 5, go ahead and contact your course 3 teachers. Stay healthy and good luck on the assessment.